Hi there, and thank you for tuning in to our training video on net metering and how net metering works with solar PV systems. These are very important questions that we get asked quite often, so we thought we'd create a little video to make it easy. So first off, grid-connected solar PV systems allow PV generation on your rooftop or ground mount or pole top, however it's mounted, to reduce the amount of energy that you will require from the grid. And it also allows surplus energy outflow to the grid during times when your solar system might be producing more than your building needs. In this situation, the grid acts like a battery, storing any surplus energy that is produced for later use. And in British Columbia, because we have so many hydroelectric facilities making up our power system capacity, effectively, every kilowatt hour that you produce yourself is a kilowatt hour worth of water stored behind a dam somewhere that can later be delivered to a different customer. So in British Columbia, grid-connected systems are permissible using the net metering programs of BC Hydro, Fortis BC, and other more local utilities such as the District of Summerland, City of Nelson, City of New Westminster, etc. So the way net metering works is something like shown in this diagram. Over on the left we have a photovoltaic array that's producing DC electricity, and then we'll have an inverter system that will be converting that DC into 120 volt, 240 volt, 60 hertz AC connection into the electrical service panel in the building. As power is generated from the solar system and delivered as AC into the electrical service panel, it's used first by the building loads. If there's a shortfall, as in this example where our solar system is producing 6,000 watts of power and the building needs 7,000, that shortfall will flow in from the grid, or so in this case an energy inflow of 1,000 watts. The net meter itself has two energy registers, one that registers energy inflow in kilowatt hours and one that registers energy outflow in kilowatt hours. At this particular instant, the solar system is producing less than what the building needs, and so we have a net inflow of power at this particular moment. In the event that the solar system produces more than the building needs, surplus power will flow out to the grid. In this case, the solar system is producing a little bit more power. The sun has come out from behind clouds, and we're now producing 8,000 watts from our solar inverter. The building still needing 7,000 leaves us with 1,000 watts of surplus, which flows out here into the grid and is registered as an energy outflow. At the end of the billing period, the customer will be billed on the difference between energy that flowed in minus energy that flowed out, hence the term net. In order to be able to connect a solar system or any other self-owned generation to the grid, we need to apply for net metering, and this is an example of a net metering application. BC Hydro will review that application and determine whether they're satisfied with what is being proposed. Subsequently, it's necessary to take out an electrical installation permit, and the system has to be installed by a qualified electrical professional. Once the system has been installed and compliance with the Canadian Electrical Code has been established, BC Hydro will allow permanent parallel operation, and they will issue permission to close the switch and connect your solar system to the grid.